In this lesson, we are going to talk about absolute value inequalities. Before we talk about absolute value inequality, let's remind everybody what an absolute value is. What is the absolute value of a number? The absolute value of a number is its distance from zero on a number line. It is how far a number is from zero on a number line. So, if you're asked to find the absolute value of -3, basically what you're asked is, how far is -3 from 0? On a number line, we have 0, -1, -2, -3. We can count 1, 2, 3. -3 is 3 units away from 0, therefore the absolute value of -3 is 3. You can ask to find the absolute value of a positive number, like +3. What is the absolute value of +3? On a number line, we have 0, 1, 2, 3. 3 is again 1, 2, 3 units away from 0. Therefore, the absolute value of 3 is 3. And if you notice, the absolute value always comes out to be positive because it is a distance. We cannot have a negative distance. So let's apply this concept now to inequalities. What if you are given a statement that looks like this? Absolute value of x minus 3 is greater than 4. How would you evaluate this? Well, you must think, because when we're talking about absolute value, we are talking about distance. So it is possible for this whole term here to have a distance that is greater than 4 on the right side of 0, and a distance that is greater than 4 on the left side of 0, because the number line expands in both directions from 0. So, from 0 here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, -1, -2, -3, -4, let's add another one, -5. So here, we want this expression, x minus 3, to come out to be greater than 4. Therefore, I should have a solution range that's going this way, not including 4, and from -4, it's going to go this way, because when it's going this way, it is further away from 0. Therefore, it has a distance that is greater than 4. So let's find the value of x that make this statement true. Okay? So here, because we have two possibilities, we have to split it into two inequalities. So we can say x minus 3 is greater than 4, and x minus 3 less than -4, as this makes sense with what we demonstrated on our absolute value, on our number line. So let's solve for x and see the value of x that would make this true. So here we have x minus 3 greater than 4. Let's isolate x. So we can do the opposite operation here, which is to add 3 on both sides. And when we do this, we have x greater than 7. Let's go to the other side here. We're going to do the opposite operation here, which is to add 3 here. And if we add 3 to this side, we must also add 3 to the other side. So we have x less than -1. So those are the two values of x that make this statement true. So let's check and see if it's true. Let's say, so we're going to check here. When x is equal to, when x is greater than 7. What is a number that is greater than 7? 8. Okay. So 8 minus 3 is greater than 4. Okay? So here we have the absolute value of 5 is greater than 4. So here we have 5 is greater than 4. So this is true, this is correct. Let's check for this one. X is less than negative 1. What is a number that is less than negative 1? Negative 2. Let's check here. X less than negative 1. So we can say negative 2. So let's plug this in the absolute value. Negative 2 minus 1. Negative 2 minus 3 is greater than 4. So here we have the absolute value of negative 5 is greater than 4. And we know the absolute value is always positive. So we have 5 is greater than 4. Again, this is true. Therefore, we have solved this problem correctly.